Alrighty, there we go. Sorry about that. And let me also change this back on Zoom. Alright. Cool. Akash, let me know if people cannot hear me, but I think I should be fine. Let me pin myself here, make myself smaller. Alright. Hi everyone. Sorry for the mild technical difficulties. Welcome to the Web3 cohort. Every Friday for the next 6 to 8 months, most probably 9 months, we're going to have a live class on Web3. What are we going to learn, Harkirat? The detailed syllabus is on blog.100xdevs.com. So feel free to go through the basic Web3 syllabus and the advanced Web3 syllabus. This will probably be 3 to 4 months. This will also be 3 to 4 months. For the next 8 months, I will see you here every Friday. That said, I will also see you Saturday and Sunday. If you are in the web dev cohort, I will also see you in offline videos. I will also see you during hackathons and on GitHub. So, few places where we will keep meeting. The goal of the Web3 cohort is to create a cohort of people who are great at blockchains and Web3. The definition of great is different for everyone, but basically try to have the same set of skills that I've gained over the last 2-ish years. My background in Web3 has been around 2 years only. September 2022 is when I started to work for a Web3 company. And since then, I've worked at almost 3 Web3 companies until now, mostly longer term arrangements, but I've taken like grants from time to time, which is fairly common in the Web3 space. So like one of these two things will, might be something that you sort of can aim for. Grants are easier to get, jobs are harder to get as always. But yeah, this is a brief of my background. If you want a detailed video, I've done it over here. I have covered all the jobs that I've gotten. I've also covered all the grants that I've gotten from various foundations. If you are looking for a quick buck, Web3 is a decent space. It's less age centric, background centric. A lot of people from non-tech backgrounds and a lot of young people get a lot of bounties. So just throwing it out there, that at least happens right now. That's probably because, at least from India, not a lot of senior people, they're a little wary of Web3. I haven't seen too many senior engineers participate in Web3 at all, at least from India. I started working in 2022, worked at almost 3 companies since. I write almost here because I consult from time to time, but primarily my full-time engagements have been 3. And primarily worked at wallets, exchanges, and gambling websites. Wallets are basically everything that you see over here: Backpack, Phantom, MetaMask. Exchanges are something like Binance, and gambling websites are something like Stake. The syllabus I've shared is going to be this. TAs, we have 5 right now. We'll see if we need more or less. Usually we've seen, only 50% of the TAs are doing any work. So this time we have tried to keep it slightly more contained with, more actionable folks. We will see. If you need more, let me know. If someone is not working, let me know. And, we can structure it accordingly. Along with this, even in web dev and in Web3, we'll be doing a bunch of cohort projects. So most, advanced people, and by advanced people, I mean, if you already know blockchains and if you've just joined for the community, I hope to see a few of you here. Right now, I've only added 2 projects. Stake is going to be led by me. It's the only project I'm going to lead in this cohort in web dev or here. Every other project is going to be led by other people. I think I get too distracted or, pick up too many responsibilities. Last time this happened and I wasn't able to review and, I had to offload to other people, which is why right now we have 2 projects. The first project is basically a gambling website. There is a lot of work to do here. The core of the work involves balances, deposits, and withdrawals. That will be done by me. And you can feel free to contribute there, but even when you're contributing to a big company, an exchange or wallet, the team would want to own this part. Anything related to private keys, anything related to balances, they would not open source. If they do open source, they would not hope for or merge a contribution from an external contributor, because these are very these are hot paths. If you contribute some bug in deposits or withdrawals, no one knows who is to blame. So for that reason, the core of that functionality I will write. But then every gambling website has like hundreds of games, so there's a lot of Web2 work to do there. Primarily Web2 work, I would say. Not a lot of Web3 work to do in a website like Stake. And the second one is TipLink. This is being led by Chaitanya. Chaitanya and I did a podcast recently. He's from cohort 2.0. During the podcast, he suggested, well, there's a longer story here, which is I was hanging out in Discord one day, and this is one of the ideas that I suggested for people to build. And during the podcast, he said he wanted to lead this project and, gave this idea of student-led projects, which I'm totally fine with. So if you feel like making something like Tiplink or contributing to it, Chaitanya will be leading it. Again, this basically means he has access to review your pull requests, merge them. That said, I should probably talk to him and structure issues a little better, and let you know. Maybe I'll create a video. Okay, if you are feeling like contributing to any of these projects, how should you start? And where should you look for features to build or the next steps? All right, so that you don't end up working a lot with an open pull request. We want to make sure you only work on a pull request that will actually get merged. All right. There might be few more projects here. If you have something to suggest, feel free to, and we can add that over here. We can also put some sort of a bounty for people who are contributing, and you as well if you're leading the project. If you want to propose a project, this might be a better way for you to propose a project. If you do want a project added here, build a V1 for it for the Super Team Hackathon. For those of you who don't know already, we are doing an exclusive hackathon with Super Team. The bounty pool is $5,000. The only problem is this month is the submission deadline, which is end of this month. The reason for this is the main Solana hackathon starts 2nd of September. So we wanted to structure this as a warm-up hackathon for the main hackathon, which is why, unfortunately, the deadline is this month. That said, I am going to prepare a few, reading materials, might take a few live classes. And I also have a list of projects that are good to pick up. Again, the expectation isn't you build any of these even before the cohort starts. The cohort is a slow, structured course over 6 months. So no one is expecting you to build anything at all or, a very big project in the next 1 month. But if you have the motivation, if you want to quickly win back the bounty or, some thing from this prize pool, feel free to try it out. I'm happy to. After the class or, after the class, maybe dive deeper into project ideas or where you can learn from. We will be learning all of this in the cohort as well. The only problem is Solana comes towards the end of the curriculum, which is why, you will have to wiggle a little bit to learn quickly if you want to build something here. The prize pool, as I said, is $5,000. At max, 50 teams will win. In the worst case, 5 teams win. So it will be $1,000 per team if that happens. So there might be a lot of upside. You might see a lot of, people participating right now, but historically in hackathons, this is seen, a lot of people participate, only few of them submissions, only few of them are submissions that are worthy of a bounty or, worthy of winning. So if you want to participate in the main Colosseum hackathon, I have also started to learn Solana like this. Only the first grant that I got was, a grant from Super Team only 4 years ago for $4,000. And that is how I started to learn Web3 and slowly, learned it enough to be able to, at least give out interviews. Cool. So great way to kick off your journey, great way to earn your first crypto rather than, buying it. Anyways, it's very hard to buy crypto from India. And these are a few project ideas. The judging criteria for the hackathon is primarily this only. I am most probably going to be the one who judges, a few people from Super Team maybe. Did you build a project on Solana? That's the brief. You can't build an Ethereum project, a Cosmos project. If you are from the ETH ecosystem already, if you know EVM or Solidity, that project won't get accepted. This is being funded by the foundation. So, it needs to be a Solana project. That's the only high level. Other than that, of course, just try to build something useful. Here are a few project ideas. Now, if you're a complete beginner to programming only, feel free to skip the hackathon. Don't get pressured. You will just feel very overwhelmed and, not even learn slowly during the cohort. So don't worry. If you're a complete beginner, it's fine. There will be other ways for you to make money eventually. If not, you learn a lot. If you are a intermediate, which means, you know a little bit of web dev, maybe you can create websites, and top level, you're able to read through docs and use APIs of other people. You can try one of these 10-11 ideas. The first one is Web3 Zapier. Zapier is a workflow automation tool. Now, I'm throwing too much jargon at complete beginners here, but try to go to zapier.com and you'll understand what Zapier is. This is also a project that we built in our last cohort. It just lets you what's called automate a few things. So basically, let me give you a quick one-on-one on what workflow automation tools are. Zapier is a big business. It is a primarily Web2 business, but a lot of companies are now building Zapier for AI or Zapier for Web3. Respell is a company that raised $5 million. Their pitch was, we are going to build Zapier for AI. Your pitch is going to be, I'm going to build Zapier for Web3. What does that mean? That basically means that the user can come and create a workflow. What is a workflow? They can come and write something like this. Hey, anytime there is a let's say none of these are good examples here, but let's say any time there is a transaction that happens on a wallet, let's say the wallet of Mark Zuckerberg or the Solana founder, so you can create a trigger that looks something like, hey, anytime the founder of Solana moves some funds, or anytime the government of US moves some funds, even the government of US has some publicly available Solana addresses. Anytime they move some funds, send me an email, send me a WhatsApp message. These are what are called workflows. Whenever there is a trigger, do a certain event. That is what you can try to build. What is the pitch? Web3 Zapier. More details you can find on build.superteam.fun. This has a bunch of ideas. I've tried to filter down, some good ideas that you can pick from here. But this is one of the ideas. If you build it well, this is also a great contender for the Colosseum hackathon. How do you build this? First, build the Web2 version of Zapier. Then add triggers like these. Anytime funds are moved for a certain wallet, you send out an email, you send out a WhatsApp message. So this and this are actually simple Web2 things. Sending out an email is a Web2 thing. But tracking someone's wallet address on chain is a Web3 thing. How can you do it? It's very easy to do if you use an API provider. I'm going to again throw a few terms here. So if you don't understand them, that is fine. But there are companies like Helios that, let you register what are called webhooks. Don't understand it, it's fine. But basically you can offload a lot of this task to an external API. You don't have to build a lot of this yourself. All right. If you did not understand, totally fine. This is slightly higher level project, probably relevant for those who've done web dev. Another project is called Whale Alert. I've also built this back in the day. Basically, if you saw the WazirX hackathon hack that happened, the first alert came out on this Twitter handle. This Twitter handle is called Cyverse Alert. Cyverse, this is a information security company that tracks the blockchain very heavily. And one of their alerts sort of figured out that a lot of money is being moved out of WazirX. There are a lot of similar Twitter handles. If you just search for Whale Alert, you might find a bunch of crypto related Twitter accounts. For example, Whale Alert here, which as the name suggests, keeps on alerting if 1562 Bitcoin have moved from here to here. 1800 Bitcoin have moved from here to here. Why do people follow these pages? Because they want to know if, more specifically, if the government is moving a lot of money to Coinbase, they're probably going to sell all of that money. Or if they're moving a lot of Solana or Ethereum to Coinbase, most probably their goal is going to be to sell it, which means there's going to be a downward pressure, which is why a lot of people follow these pages. Believe it or not, even our page called Tech Alerts, where we post a bunch of remote job offerings, was heavily inspired by this, where I saw a bunch of these pages do very well, and we just created tech alerts from it. All right. So Whale Alerts, again, you have to track a bunch of addresses on chain. You can tweet from it. You can give out an API to other people. Maybe creating a Twitter bot is a great starting point. Liquidating NFTs to a token. Again, this is too much jargon, so let me not speak too much about it. You can read more details here. But if you understand what NFTs are, if you understand what a token is, then feel free to build this. If not, that is fine. Again, a high level project. This might be a simpler one. A NFT viewing gallery. Again, this involves you knowing what an NFT is, which we will cover eventually, but high level. You can buy these things called NFTs. You might have heard of them, non-fungible tokens. Sometimes they are really expensive. And a place where users can come and see all the NFTs they own in 3D is a decent project to build. Not too much utility here. It will just teach you a bit about libraries like 3JS or Babylon.js, and a little bit about how can you query the blockchain for what NFTs a user owns. For example, if I open a wallet over here, you will see it has a tab called collectibles, which is the NFTs I own. For example, I own this Mad Lad NFT and this one more NFT. If I could go to a website and see this picture in 3D and see this picture in 3D, that is basically what I'm trying to say that you build here. Again, not a lot of utility, but decent project to build here that gives you an idea of how at least you can query addresses for NFTs. Decentralized Fiverr, slightly harder, but basically a marketplace where people can come and put up their proof of work. Basically, the front end needs to be as close to Fiverr as possible. A place where freelancers can come, put up, I want to do this, I want to do that. And then a person who wants to hire them can come. The person who is hiring them can pay them via crypto. That is the only extra thing that you have to do, other than what happens in Fiverr. So basically build a Web2 version of Fiverr, then add payments using crypto on top. If you want to go one step ahead, you can create what's called an escrow. Escrow basically means before a task begins, before you actually hire someone, you put some money somewhere. You put like let's say $1,000 in an escrow. When the job is done, the developer can pull that money out from the escrow. And escrow is a central place where the money is kept, and after the assignment is done, the money is moved to the developer. In case either of the parties is unhappy, if the developer says Kyar, he's making me do too much work, refund them the money. Or the person who's hiring says Kyar, he has not worked at all, I don't want to pay him. Then the escrow becomes the source of truth. A human comes and then transfers the money the right place. The same thing happens on Upwork, right? If you are ever on Upwork, you will ask your client to escrow money. Kyar, first put $5,000 in an escrow, so Upwork owns it. If there is a dispute, then Upwork comes in the middle and handles the dispute and distributes money the right way. So if you want to go one step ahead, feel free to build an escrow. RPC aggregator. For this, you need to know what an RPC is to begin with. But basically, I'm asking you to build something like Iron Forge. This is a company that won Colosseum a few years ago, maybe 2 years ago or something like that. This guy also worked at Backpack, the founder of this company. And they were building something different before. I think what they've pivoted to now finally is a place that aggregates RPCs. Now, if you don't know what RPC is, then feel free to ignore this. But anytime you want to query the blockchain, even when I opened my wallet over here and saw 2 NFTs, I sent a HTTP request somewhere. Now, if you don't know what an HTTP request is, it is fine. I basically went to a website like nft.solana.com to get the NFTs that this address has. These are what are called RPC URLs. There are a bunch of even multi-billion-dollar companies. For example, Alchemy is a company that was worth $10 billion in the last bull run, which means they're also worth the same today. They provide you RPC URLs. Similarly, Helios is a company that raised 30 million or something like that in their series A fairly recently, like 6 months ago. They also provide you. Solana's leading RPC platform. RPC aggregator is just you aggregate all of these in a single place, and you have to find which one of these RPCs has the minimal latency. What is the best RPC that I can go to that will give me my NFTs as soon as possible. So that is what an RPC aggregator is. You can go to Iron Forge, sign up, and you will understand this a little bit better. But if you don't understand, again, it's fine. Some of these are complex projects that involve a lot of jargon. For example, RPC, NFTs. So don't worry about them if you don't understand. Ignore this. This is a little too hard. But if you want to talk more about this, I'm happy to talk after the class. YouTube channel opinions market. Before that, you should understand what is an opinions market. You should go to this video between me and Kunal. Kunal is one of the oldest engineers in Solana in the country. He is currently working on a Twitter-based opinion market. I'm asking you to replicate the same thing for YouTube. The company that he's co-founding was also a winner in the last hackathon. So basically, let users speculate on channels. This specific channel, let's say Hakira's channel, is doing really well. I want to buy some shares of this channel. And Harkirat can, whenever Harkirat wants, he can go to your website and claim some of that money. Again, happy to talk after the class. Just giving a high level right now so we can proceed to, some more important bits. And, I don't confuse too many people. Tip link. As I said, we're already building this in the cohort, but you can try to build it as well. Tip link is wallet as a service. My recent video on YouTube sort of builds the same thing. So, worst case, you can try to copy it and add some more features on top. Again, if you don't understand, it's fine. But it's a good project to build. They also either won Colosseum, was second or something like that, ended up raising $6 million. So a decent project to build. The reason they ended up winning, I think they won Colosseum a few years ago, was because they brought very nice UX to crypto. Right now, this is how I own my crypto. Okay, I have this extension inside which this money is kept. Versus TipLink gives you a website very similar to a bank. So if I go to tiplink.io, I get a very simple website where I can see the funds that I own compared to storing them in an extension. That is why, for example, I own $10 here. This looks like HDFC Bank website, right? Which is why this was very good UX. The first time even I tried what they had built, it wasn't exactly this. It was something around tipping, which is why it's called TipLink. but it was very good UX to, see someone build something like this. You don't even need a wallet. You can, create a wallet with your email basically. That is why it is called wallet as a service. But if you don't understand this, again, this is fine. Good project to build though. GitHub bounty dispenser. Again, there are a bunch of websites that let you do this. Algora.io is basically a website that lets you do it. What does the website say? Bounties made simple. It basically lets you dispense bounties directly from GitHub. So if you go to, a bunch of these open source projects, you will see they are paying developers directly from GitHub. We want to build something similar. For example, all of the repositories that we have, I repeat, all of the repositories that we have on GitHub where people contribute from time to time, we also dispense out bounties. For example, this is a pull. Now, if you don't understand this, it's fine. Feel free to ignore the next 10 seconds. But anytime someone contributes to our repository, it would be nice for us to, assign them a bounty directly from here. Okay, hey, thank you for your work. Here is a bounty, $20. And as soon as I comment, $20 reach their Solana address. That is what we want to build in this specific GitHub bounty dispenser project. A few people already tried this in the last hackathon. It was half built, half not built. So if you are thinking of building this, try to build this as close to Algora as possible. And lastly, a UI library for Solana. UI libraries, some of you might have heard of things like ShadCN. A lot of people are now building ShadCN for AI. It's basically a component library. A component library means they give you some very pretty components that you can bring onto your website. For example, this pagination component. It's very hard to build this from scratch, right? It involves a lot of CSS, buttons, next, previous, so on and so forth, which is why it's easy if someone has written it. If you guys don't already know Manu came to the hackathon. He also has a company called Certainty UI, which is very similar to ShadCN. And he also lets people, build components like this. This over here is Manu. He's the founder of Certainty. He also came in the Delhi meetup as a speaker. So building this, but for Solana, if you go to any Solana website, for example, you saw these two NFTs over here, right? These have some basic UI, right? The title is written over here. It says staked over here. It is rounded, has the image. So building a bunch of these components so that if Backpack in the future wants to, let's say, integrate NFTs, they directly use your UI library. They don't write all of the logic from scratch. That is the last idea I have. I'm happy to talk through all of these ideas at the end of the class. If you have any, your own ideas, or if you did not understand anything, we'll do it at the end of the class. I want to make sure I finish orientation first, because for complete beginners, there might be a little too much ekdam se. So I want to make sure, we get back a bit and discuss about blockchains 101. I'm going to very briefly take you through why blockchains, how to create a new currency, some introduction to hashing and proof of work. Very little code we will be writing, and understanding how blockchains work, why they were introduced. We will try our best to not reach the first slide. The last slide. The last slide is intro to blockchains. Bitcoin. It basically takes you through the Bitcoin white paper, but we'll try to avoid that today. We'll keep it simple. We will focus only on why blockchains and how can you build your own. All right. Let me do a quick poll to just do a vibe check. Are we clear? Was the first section understandable, comprehensible? Yes or no? The first section was comprehensible. Great. We have a good audience then. Perfect. 94% says comprehensible. That is great. Again, at the end of the class, we can discuss more ideas. Let's quickly get into why blockchains then, guys. Seems like a fad, right? Everyone keeps saying Web3 is a fad. There's no use case. But let's understand the core motivation of building a blockchain that came in 2008. There was no concept of at least blockchains and tokens and Bitcoin and Ethereum before 2008. But something happened in 2008 that, it was happening for years, but 2008, it happened at a very big level. It motivated a few cryptocurrency researchers to build Bitcoin. What were the problems that they saw? And what are real problems that you should actually worry about? Maybe you don't worry about them right now, but 10 years, 20 years from now, there is a high probability that currencies just, bloat. By bloat, I mean, there is very high inflation everywhere. That is purely based on how currencies work right now. believe it or not, currencies, INR, US dollars are a very fresh concept, only 100 years old. Before that, we had the barter system, and you give me maize, I give you shoes, kind of things used to happen. Eventually, gold came into the picture. People started to use gold as a store of value and exchange assets between one another, and then eventually currencies were introduced. Government has been printing currencies left, right, and center. For those of you who don't know, this is a chart. Okay, how much of US dollar is printed, and especially if you look at 2020, I mean the slope is just going up, as you can see. It was fairly mild for years. The government did not print a lot of money, but that became fairly high after 2008, and during COVID it just went bonkers. This is why people kept on saying that inflation is very high during COVID, or generally after COVID. Have you ever thought of this? I was fairly dumb when I joined Goldman. When I was going through my Goldman orientation, I asked them a question. Okay, why does the government not print a lot of money and give them to everyone? How many of you know the answer to this? Why can't everyone here be rich? Why don't we just... Do you know the answer to this? Why don't we just print money and give everyone 1 crore rupees or 10 crore rupees? Do you know the answer? Well, most people do. I was fairly dumb when I was, 22. I did not. So I asked this, got a little bit of chuckle. Most of my friends surprisingly also knew this, like non-CS friends, civil engineering friends knew this. I did not know this. And the answer is inflation. If you just print a lot of money and give it to everyone, everything will inherently become expensive. People will have, more money to spend. The prices of everything will go up. People will just spend that money again and again. So if I have 500 rupees and the government gives everyone, doubles up their bank account, everything will also become twice as expensive because money will lose value. If, currently you have some gold, my mom has some gold. Let's say I get a lot of gold. I get like millions and billions dollars worth of gold. Then, the value of gold will go down. I will be like, mere paas to itna pada hai. I have so much gold back home. I will start selling it to everyone. You take it in 10 rupees. You take it in 20 rupees. I have so much gold back home. I will start to undercut everyone. If there is anyone around the world who's willing to sell gold, I will be like, no, take it from me. I'll give you the best price because I got a lot of inflation. I got a lot of inflated gold in my house. So whenever you print a lot of money and give it to people, it does not mean everyone becomes rich. It just means everything becomes more expensive because the value of that rupee goes down. That has historically been happening, and the problem is you have no control over it. The government decides how much to print, when to print, who to give, who not to give, who to bail out, who not to bail out. This specific peak happened because they were giving out everyone's stimulus checks, which is sort of justified. Chalo thoda bahut. They gave everyone money. But what happened back in what happened back in 2008 was these big banks were... So you should watch this movie. If you really want to do something today after the class, and if you have the time, and I'm also happy to stick around and watch, even though, I don't think Netflix lets me screen share, and this is only available on Netflix. There's a very nice movie called The Big Short. This is suggested to everyone who joins Goldman. And there's another one, I'm forgetting the name now. This is the better version. It basically takes you through what happened in 2008. And what happened in 2008 was people hated banks. People generally hate Wall Street. And, if you've ever been to New York, you'll see, you get side eye from people of New York when you're traveling around Wall Street. The reason for this is they know, number one, bankers make a lot of money. Number two, they make money in a shady way. They're, a lot of times betting and gambling. That's exactly what was happening in 2008. They were inflating an instrument called mortgaged backed securities. Again, this is a great movie to watch if you want to understand this and, actually want to understand what was happening then. But they were basically inflating this. They were basically gambling a lot on a security that was highly inflated, and eventually that just went bust. The price of that security went down. They were over leveraged on that security. A lot of banks became bankrupt. They owed a lot of people a lot of money. They did not have that kind of money, and hence these banks were supposed to go down. Ideally, these banks should have just shut down, declared bankruptcy, and gone out of existence. But the government said, if every bank goes out of existence, then probably the whole country's financial system will collapse. And they bailed them out. They said, we will pay your fine. You are bankrupt right now. You need $50 billion. It's okay. We will pay your $50 billion. Where was this $50 billion that government was bailing them out coming from? It was coming from the average person, right? The taxpayer. So they took all the taxpayer money and gave it to these big banks. This is where the biggest conflict came. Who is the government to decide? Why does the government get to decide who to bail out, who to not? These people were, I also like to gamble in my free time. Does that mean if I ever lose a lot of money, the government will bail me out? No. So why did they bail out the big banks? This is when people realized that you can't trust currencies at all. The government does whatever it wants. We will create our own currency. This was the introduction of blockchains. Now you might ask, Sarkirath, why do you need a blockchain if you want to build a new currency? That is a different question we will be coming to, but that is what initiated Bitcoin. Another reason, you need blockchains, or more specifically, you need a new currency. That is the only reason blockchains were introduced back in 2008. Today they do 100 different things. But the initial goal was, we need a better currency. This US dollar currency, this INR currency, only few people, get to choose when this gets printed, who this goes to. We don't want that. We want an open currency that can be tracked by everyone. The other reason is you can't really trust banks. You might think you can, but you can't. Banks run on something called fractional reserve banking, which basically means they don't have everyone's money. If everyone today goes to HDFC Bank and wants to pull out their funds, they don't have your money. They've already lent it out, right? They make money by lending out your money to other people. They just need to hold, let's say, 10% or 20% of the balances. Everything else they lend out. This leads to banks also collapsing. When FTX collapsed, there was a lot of backlash, rightfully so. But a few months afterwards, believe it or not, so my company that I was working at had $14 million in FTX and $6 million in a bank. And when FTX collapse happened, the founders were trying their best to calm all the engineers. Okay, we still have funds. It's fine. We lost 14 million, but we still have 5 million in the bank. We have 2 years of runway. And the day SVB collapsed, the first thing I was in the US only back then. The first thing I asked my boss was, okay, did we have the rest of our money in SVB? He said, no. Thankfully, we had it in, a better bank. But if some of you met Samir at the meetup, Delhi meetup, he's the founder of Apex, which is funded by Y Combinator. Every company, not every, but almost every company that is funded by Y Combinator had their funds in this bank called Silicon Valley Bank. The founder of Y Combinator, they themselves suggested to keep your money in Silicon Valley Bank. So that specific day when this bank collapsed, March 2023, I think. Yeah, March 2023. The day this bank collapsed, Samir was calling me. He told me YC group was going bonkers. The founders of Razorpay or every billion-dollar company in India, they have their personal funds in SVB because they have a lot of money. Everyone was like it here, the money is gone. Thankfully or unthankfully, the government bailed them out as well. Government sort of paid everyone the money. This bank eventually closed and everyone moved their funds on to Chase. Everyone moved on. So even banks go down. This is another reason you should not trust a central entity with your money. Even a bank as big as SVB, which had been around for years, which Y Combinator everyone was suggesting, take our money. Y Combinator funds you. And they were funding your company by putting money in SVB. Even they, the smartest people in the world, did not know SVB would go down, right? So that is the reason, currencies are just weird. I know it doesn't feel that way. To me also did not for a long time, but now I don't trust currencies too much. I hate keeping INR and that doesn't mean I keep buying Bitcoin. It just means I tend to keep money in assets, which is, standard advice you will give finance, which Sharan give from time to time. Don't keep cash, which is, good advice because money depreciates very quickly over time. Inflation is really high. The other reason is, especially it's worse in India. The US dollar in itself is screwed and, high inflation, but Indian rupee also loses value to US dollar even worse. So now if you look at the chart, this is just from some 2016 until now, you make, more and more, the US dollar price keeps going up. Now, when I was a dumb engineer, I used to be like, I make 100K a year. That used to be 70 lakh over here. That became 85 lakh. So my dumb mind told me, bro, I'm becoming richer. Every year, even though my salary remains the same 100K, I used to make 70 lakh over here because the conversion was 70 lakhs. Now I make 83 lakhs. But realistically, should you be happy? No, it means the Indian currency is losing. I still make 100K only. And the global reserve currency is the US dollar. So it doesn't matter how much INR you make. Don't be happy about this. If this goes up, does not mean India is progressing. Does not mean you're being richer if you're getting more money. You had a 100K offer. If this becomes 100 tomorrow, you make 1 CR a year. That doesn't mean it's a good thing. It means it's a bad thing because your current country's currency is losing value. You got that 1 CR. Next year, this money inflated even more. That one CR is just $80,000 now. Next year, this inflated more. That's just $60,000 now. So you are actually losing value compared to the global reserve currency. This is even worse in countries like Japan. I don't know if you've heard of Venezuela. There are countries that have extremely high inflation. Every day, money loses its value, becomes half. That is where, those people are now finally even in Japan. So my company moved to Japan. All of us moved to Japan. Everyone bought fairly minimal Japanese yen. Okay, we will keep our money in crypto. People, these were very rich people, so they were buying like 100k worth of yen. But I also like bought, enough to get me through the month. And then I was like, I'll buy more next month, because Japanese yen also performs fairly poorly compared to even INR, but US dollars as well. All right. Currencies are not backed by anything anymore. When currencies were introduced, government said, KR, barter system is very unoptimal. Handling gold is very unoptimal. So we will introduce this money. Anytime this money is a contract. If you give us this money, we will give you gold in return. It still happens. Today also, I think you get back some treasuries if you give them $100. But historically, this used to be backed by real assets. KR, we are giving this piece of paper because it's just easier to transact. If you ever want this converted back to an asset, give us 100 rupees, we'll give you 100 grams of gold. That backing went away a few years ago. Now the government just prints money left, right, and center. Versus when they introduced it with very good intentions. Okay, handling gold is really difficult, so let's just handle, paper money. Alrighty. Now the question is how to create a new currency. What I've introduced is currencies are bad, countries are bad, and governments you shouldn't trust. Question is, how can you create a new currency? Can I come out today and say, screw the government, I am creating new notes, everyone use my notes? Do you think anyone will trust me? Even if they do you think that's a good thing? No. Now I can inflate money, right? Now I am the central source of truth. Creating a new currency is generally very difficult unless you have a central entity. If I create my own bank today and say, I'm going to issue Kirat coin to everyone who works for me, and you can use Kirat coin at your Kiryana shop. The Kiryana shop owner also wants Kirat coin. Let's say I convince everyone in the world that Kirat coin is the best currency for whatever reason. There is still a Kirat bank in the middle. I can still inflate money and you guys wouldn't know. What is the most trustless way to build a new currency? That is what the Bitcoin paper introduced. KR, there's no point introducing a new currency. There will always be a central entity. How can we build a new currency without a central entity is what Bitcoin introduced. That is the best use case of blockchains till date. Anonymized, decentralized money. Everything else are the good use cases on top are just platforms that let people exchange this. If you want to convert Bitcoin to Ethereum, Ethereum to Bitcoin, you go to an exchange. Exchange is a good business. Binance, Coinbase, good business. If you want to do this in a truly decentralized fashion, wallets. Wallets are a good business, but the underlying thing they are providing you is just letting you swap one asset to another. The asset in itself is the innovation that came from blockchains. All right. I hope you understand why creating a Kirat coin is a bad idea. So the question is, how can you create a decentralized source of a decentralized currency, by which I mean no single person can create more Bitcoin or more Kirat coin. If they are creating it, they need to tell everyone I am creating it. There needs to be an algorithm through they are created and distributed. How can you create something like this? This is where the Bitcoin white paper came. Now, the Bitcoin white paper was written by cryptographers who know cryptography very well. We don't, which is why first we will have to do a hashing 101 and understand a little bit about proof of work before we can get to the Bitcoin white paper. So let's do a quick hashing 101 before that. Let me do a quick poll to understand. Do you guys already know what hashing is? How many of us already know what hashing is? Understand SHA-256 hashes. Okay, 50-50, 60-40. Cool. It's a 50-50, which is totally fine. We'll be going through, as I said, classes are going to be very slow and manageable for the cohort 3.0. So we're going to go through hashing again. If you think classes are going really slow, I would just urge you to open the white paper and start to go through it. Today I was going through a very nice video also. Just search for Bitcoin white paper animations. Very nice animated video that will, take you through the same thing. All right. Introduction to hashing. Hash. So never mind. Let me just go through the slides. I just wanted to introduce another thing called encryption, but let's do that later on. Hashing is basically this. Given a string, how can you pass it through a function? What does a function mean? Basically some code that you might have written, so that you're able to spit out a fixed size string such that given this, you cannot create the original string. I repeat, अगर मैंने 100x devs डाला, if I send 100x devs as an input, whatever comes out is highly randomized, looks very ugly, is not predictable. If I hide this over here, if I put my hand over here, I cannot look at 100x devs and predict the outcome. No, I have to pass it through a hashing function. This function does a lot of complicated things. And then this very long string comes out. This string is what's called a hash. What are the properties of a hash? Hashing is a process that transforms an input data into a fixed size string of characters. If you have gone through cohort 2, you might remember we used hashing when we were hashing passwords so that we don't store them in plain text in the database. If your user comes to your website and gives you a password, you don't store it like this. If the password is I love Priya, you don't store I love Priya in the database. You hash it, you store this hash in the database so that the developers of Facebook, for example, don't know that my password is I love Priya. So another use case of hashing is passwords. We will get to this when we reach, sign up, sign ins in the web development cohort. Hash function has several important properties. Number one, deterministic. The same input will always give the same output. If I write 100x devs and pass it through a specific hashing algorithm, it should always give the same outcome. This isn't random different outcomes that can come out. If I am running a hashing algorithm on my laptop and you are running one on your laptop, for both of us, if we give 100x devs as the input, the output should be this thing that you see on the right. Fast computation, the hash function needs to be extremely fast and compute this data as quickly as possible. Pre-image resistance. What does pre-image resistance mean? What is the pre-image of this? It is this original string. So pre-image resistance means what? It should be computationally infeasible to reverse the hash function. Given this, if I hide the thing on the left from my hand, I can't predict कि 100x devs था. If you were at the Delhi meetup, if you remember the puzzle that we were giving to everyone, we were actually giving everyone this. If you came to the Delhi meetup, we were handing over a bunch of sheets. On those sheets, this was written, and we asked you to predict what this original string is. Pre-image resistance. We gave you this. You could not predict the original string. So how would you get the answer during the Delhi meetup? I repeat, when we had a Delhi meetup, we were giving everyone sheets on which such a hash was written. And we said, whoever figures out the original string, we will give you some keyboard. We will get to how you can, given this, predict the original string. But generally when you're hashing, it should be computationally infeasible. You can't reverse engineer from here to here. The only thing you can do, and the only thing that was expected from students in the Delhi meetup, was that they brute force the inputs. When we gave them this, we gave them the syllabus as well, the syllabus of the cohort. And the syllabus had things like Bitcoin, Ethereum, monorepo. So what the students were expected to do was put Ethereum in a hash function, find the output and compare it with what you have on your sheet. You have a sheet which has this hash. You have the syllabus right above it. Put the first thing in the syllabus, Ethereum, in a hash function, find the output, compare it. This is what's called a brute force attack. We asked them, or we expected them to brute force through the syllabus, take everything from the syllabus, Bitcoin, Ethereum, monorepos, hashing, pass them into a specific hash function, find the output, compare the output with what they had on their sheet. That is how, we wanted them to find the input. Whoever did, was given a prize. Because of this property of hashes, they couldn't just reverse engineer. They had to brute force through all the things that are part of the syllabus. If you did not understand this, we'll explain this a little bit more when we reach the next slide. Small changes in input produce large changes in output. If I change this from 100x devs to 200x devs, the final thing will be highly unpredictable. It will not have 557. It will have some 932188. It will be very different. If I change one letter over here, doesn't mean one letter changes over here. A lot of letters over here change. Collision resistance. The probability of two input strings having the same output is very low, almost impossible. Of course, there can be a collision. There are infinite number of inputs that you can give here. There are only finite number of outputs that you can give here. So if there are infinite number of inputs over here, of course, two inputs will eventually lead to the same output because the number of strings that you can create here are finite. That said, sorry, I just got an alert. The probability of that happening is really low. That is what this collision resistance says, point says. All right. Now tell me this. Do you think this is a hashing algorithm? This might be common if you've ever done, basic infosec ka course. I am hashing it this way. If this is the input, I will just add 1 to everything. 1 becomes 2, 0 becomes 1, 0 becomes 1, x becomes y, so on and so forth. What am I doing? I'm just increasing every letter by 1 letter after it. Do you think this is hashing or do you think this is not hashing? Does it follow all the properties that I have mentioned over here? Is it deterministic? It is deterministic. 100x devs ke liye, the output will always be 211YEWT. Again, what have I done? I have increased s by what comes after s? T. So I have replaced this s with t. What comes after v? U, v, w. So I have replaced this with w. Is it deterministic? It is deterministic. For the same input, output is the same. Is it fast computation? It is fast computation. Does it have pre-image resistance? It does not. If I know the hashing algorithm, I can reverse it, right? I know that all I have to do is decrease 1 from here. That will be the first input. Decrease 1 from here. That will be the first input, so on and so forth. So this is not a hashing algorithm. This is actually closer to encryption. What is the difference between hashing and encryption? Encryption is two-way. If I encrypt something, I can also decrypt it. If I hash something, I cannot unhash it. Over here, if I hide the thing on the left, I can still predict the thing on the left if I know the hashing algorithm, which is why this is not a hash. This is more closer to encryption. Let's go through a famous hashing algorithm. I've talked a bit about hashing. Try going to this link that I'll mention in the chat as well. Try going to this link and putting a simple string over here, put 100x devs. If you put 100x devs on your machine, or if I put it on my machine, we will see the same output over here. Was that one of the expected properties? Deterministic? Yes. Is there determinism? There indeed is. If we both put the same string, the same output comes. The output is highly randomized. Given this output, I cannot predict the original string. The algorithm that we're using over here is called SHA-256. There are many popular hashing algorithms. SHA-256 is the commonly used one, but you can use a different one as well, as long as it is following these properties that we have talked about here. This though is a simple website, which is great for you to try out. But what if I ask you to write some code now? Now, some of you know JavaScript, some of you don't know JavaScript. There was a mild prerequisite of JavaScript in the Web3 cohort. If you think you don't know it yet, it is fine. But React and JavaScript are two prerequisites. Happy to put the videos from the web dev cohort here if you don't know it. But if you are in the web dev cohort, you're fine. You'll learn it there. If you're not, little bit you'll have to chew glass and understand these 4 lines of code. What are these 4 lines of JavaScript code doing? They are using this library called crypto, which stands for cryptography in Node.js. They're taking an input string, let's say 100x devs, and they're creating a hash from it by using the create hash function from the crypto library. What is the create hash function? Crypto.createHash, if you call with a specific algorithm, if you call crypto.createHash with a specific algorithm, the algorithm that we are using is SHA-256. This returns an object on which if you call .update with some input, let's say the input is 100x devs, that returns an object. If you call .digest on it with a specific encoding, Harkiyat, what is encoding? Basically SHA-256, as the name suggests, the final output is a 256 bit object, or basically 256 bits. Kirat, what is a bit? A bit is a 0 or a 1, right? If you've done basic computer science 101, the way computers store data is in the form of bits and bytes, if you might have heard of them. A bit is basically a 0 or a 1, and every string that you see over here, let's say I write Harkirat as a string, the way my computer interprets it is based on a bunch of zeros and ones, and these zeros and ones are what are called bits. What does SHA-256 say? It says the final output will be 256 bits. I repeat, it will be 256 such bits. So can you predict the number of possibilities? How many total number of possible outputs are there? It will be 2 to the power 256, right? If you do basic permutation combination, if there are 256 bits available, then what are the total number of outputs available? It is 2 raised to the power 256. Now you might ask, Harkirat, you are saying the output is 256 bits. Why is the output coming as numbers over here or letters over here? Because I have selected the output encoding to be hex. I have said I want the output to come out as hexadecimal. What is hexadecimal? Basically just combines a few of these bits. It combines, let's say, the first 4 of these bits, and whatever is the output of these first 4. If you know a little bit of binary, what is 0, 1, 1, 0 in binary when you convert to a number? It is 0 plus 4 plus 2 plus 0. Harkirat, mind is blown. What is this thing you have done over here? For this, you need to understand what binary is first, and how can you convert a number to a binary representation? How can you convert binary representation to numbers? Let me do a poll and understand how many of us already understand this. And if 90% plus already understand this, I will just proceed. Do we already understand conversion from bits to numbers, numbers to bits? Have you ever done binary before? All right, we don't understand this. It is fine. As I said, guys, we're going to go slow. So I will have to take a detour for the next 10 minutes and explain hexadecimal. If you want to quickly sprint, then try writing this code to understand a few hashes, and then there are a bunch of assignments in the next specific section. Try to go through these 4 assignments, and then lastly, go to andersbrownworth.com/blockchain and go through this first video over here. Try to play with these things over here. Okay? If the class is feeling slow to you, go to the next slide. Try to do the 4 assignments I've mentioned. There are solutions, but try to code it yourself. And in the end, try going here. All right. I'm going to take a 10-minute detour now. And if you're done with this, feel free to drop off. If you're done with this, if you want, you can read the white paper. If not, I will read the white paper in a different video, most probably in a structured offline video. Maybe I'll take you through basics, but quickly go through the next slide. Feel free to drop off after that. And I will see you in an offline video. All right. For everyone else, basically, binary is a format in which you can store numbers. For example, right now you write numbers usually like this: const number equal to 100. Binary says, oh God, this is taking me back to my data structures and algorithms days. Binary says, here you can also represent this number in a different format. You can represent this number in the form of zeros and ones. How can you do that? You break this down into a bunch of 2 to the power additions. Harkirat, 2 to the power additions. Yes, let me explain this a bit. Let's take a smaller number. Let's say the number was 16. Let's say the input number was 16. And my question to you was, convert this into a binary. How would you convert 16 into a binary? The answer is, the first bit would be 0. Why? Because the final output, I repeat, the final output of this binary is going to be whatever is present over here into 2 to the power 0. I repeat, 0 into 2 to the power 0. What is 2 to the power 0? It is 1. So it is going to be, the final output is going to be 0 into 1 plus whatever is present over here, which I'm going to again put 0 over here, whatever is present over here into 2 raised to the power 1 plus whatever is present over here into 2 raised to the power 2 plus whatever is present over here 2, 4, 8, 16, 1 into 2 raised to the power 3. Let me ignore this one now. The binary representation of 16 is 1000. Why is that? Harkirat, why is the binary representation of 16 this? Because given a binary number, the way to convert it into a decimal number is by taking the last bit and multiplying it by 2 to the power 0. So what is 0 into 2 to the power 0? What is 0 into 1? It is 0. What is 0 into 2 raised to the power 1? It is 0. What is 0 into 2 raised to the power 2? It is 0. What is 1? Sorry, this is 1 over here. So 1 into 2 raised to the power 3 is 16, right? 2, 4, 8. We need another one. Something like this. This will also be 0. And this will be 1. 1, 2, 4, 8, 16. Yes. The binary representation of 16 is 10000. Harkirat nahi samajh aaya. Try going here. Convert number to binary. Search for convert number to binary. Find some, online converter. Put 16 over here. Convert. What does it say? 10000. Why? Because why is the representation of 16 10000? Because the way to convert this back to the original number is multiply the last bit by 1, multiply this bit by 2, this bit by 4, this bit by 8, and this bit by 16. Since all of these are 0, 1 into 16 is 16, which is why the binary representation of 16 is 10000. Can I try a different number? 1. What is the binary representation of 1? It is 1. Because 1 into 2 raised to the power 0. I repeat. 1. And let's put all of these as 0. What is 1 into 2 raised to the power 0? It is 1 into 1. Anything raised to the power 0 is 1. 1 into 1 is 1. So this becomes 1. And everything else is 0. That is why the binary representation of, if the input was 1, the output also came out to be 1. If the input is 1000, then the binary representation looks something like this. All right. Play with this a little bit. If you still did not understand it, it is fine. I would hope 5-10% also understood this a little bit better. If not, play with this a little bit. Google or ChatGPT how to convert numbers to binary, how to convert binary to numbers, and try to understand how this representation works. Whenever in JavaScript you are writing, whatever const x equal to 100, this 100 is eventually getting stored in such bits in this specific format, because your machine only has, transistors which have a value of 0 to 1. If you really want to go extremely low level, everything that you write, even when you write strings, right? Const name equal to Harkirat, this h is actually converted into a bunch of bits only. This h is converted into a bunch of bits, which is what, gets stored in my laptop. Cool. All right. I took you through all of this just to tell you, okay, the final encoding that we convert our bytes into is a bunch of hexadecimal digits. Hexadecimal digits basically means anything from 0 to basically means the digits can be either 0 or 1 or 2 or 3 or 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. It can only be one of these 16 digits. The final outcome can only have either 0, 1, 2, 3, 4 up to F, which is why if you really look at my output here, you will only see either F here or C, D, 2, 0, 1. You will not see Z over here. You will not see X, Y, Z over here. Why? Because a hexadecimal representation, as the name suggests, will only have 16 characters, and these are the 16 characters that we support. What is the encryption algorithm? The encryption algorithm is SHA-256. Since it has 256 bits. I repeat, it has 256 bits as the final outcome. The final outcome has 256 bits. If you convert 256 bits into hexadecimal, it will be 256 divided by 4, right? It will be 256 divided by 4, which will be 32. What is 32 into 4? By 4 or 5. Nee, 8, sorry, 32. It will be 256 divided by 8. Why? Okay, I'm doing a bunch of math here. If you don't understand it, it's fine. Okay, high level is, okay, this final string is of how many characters does it have? How many characters does our final string have? It has character count 64 characters. It has 64 characters, which means it was indeed 256 divided by 4 equal to 64. All right, which means the final output, which was 256 bits. I repeat, the final output, which was 256 bits, is grouped into first 4. These first 4, okay, I'm doing too much math here, but I hope you understand these first 4 can go from 0 to 15, because if all of them are 1, then it will be 1 plus 2 plus 4 plus 8, which is equal to 15. And based on, if it is 0, then we pick 0 from here. If it is 1, then we pick 1 from here. If it is 2, then we pick 2 from here. If it is 15, then we pick F from here. That is how a 256 bit long output is converted into a string that is 64 bits. I repeat, the 256 bit output is converted into this string right here by taking, the first 4 bits together first, then finding what do these first 4 bits represent. If it was 1, 0, 0, 0, then what is this when converted to a number? It is 1, right? Which means I'll pick the first value over here. If it was 0, 0, 0, 0, then I will pick 0 over here. If it was all 1s, then I will pick F over here, because 1 into 2 is per. If it is all 1s, it means it is 15. If it is 15, it means I will pick the last one. If it was 14, I will pick the second last, so on and so forth. So that is why the final string that you see is 64 characters, which is 256 bits. Do we understand this? Hopefully we do. Took a mild detour here. Do we understand encodings and the final output? How does it look like? Why does it look like this? Great. Perfect. Beautiful. So now let's write some code. Hopefully some of you have Node.js locally. The ones that don't can go to Replit, I would hope. The ones that don't can go to repl.it, quickly log in over here. Even though if everyone goes here, it will just break. So if you have Node.js locally, just use your local Node.js. Don't log in over here like I am. After you log in on replit.com, click on create REPL over here. Select Node.js as the environment and click on create REPL. Once you do, you should see a screen like this. Now, most probably this will break for some people if everyone starts this together. But if it does not break for you, just paste the code that I had written, click on run, and you should hopefully see an output over here. The output being the exact same thing as the output that we got here. It is deterministic. If 100x devs is the input, this is the output. If you want to run the same thing locally, open, whatever, your Node.js compiler. If you have Node.js locally, I'm assuming you already know how to run this, so I'm not going to take you through that. If you don't have Node.js locally right now, then simply paste it over here. If you do have Node.js, you know what to do. Open your terminal. Yep, I shared my database credentials. 838. rm-index.js, v-index.js. Paste the code in some index.js file and then run node index.js. That's how you can run the same thing locally. We are going to run this on Replit for now. I hope you understand these 4 lines of code. Const hash equal to crypto.create hash.update.digest. If you do understand this, let's go through some assignments next, where you will try to code a few things. All right. The goal of the assignments is to understand this thing called proof of work. I need you guys to show me that you have done some work. I need you guys to prove to me that your machine is doing some work. Okay? Let's see how you're supposed to do that. Again, you can use this as a starter code. You can use this as a starter code and try to code on top of it. What if I ask you the following question? Give me an input string that outputs a SHA-256 that starts with 5 zeros. How will you do it? Ignore the answer. Well, feel free to read through the answer and try to implement the code for it. You will have to brute force until you find a value that starts with 5 zeros. I repeat, if I go over here, I can now start to brute force. Kya 1 का output क्या है? अच्छा 6 है. What is the output of 2? This 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I will keep writing this again and again until I find an output that starts with 1, 2, 3, 4, 5. 5 zeros. So I can either keep doing this all day. Let me predict 20, or keep writing until I find something that I saw something that started with 1 0. I found something that starts with 1 0. I want you to find something that starts with 5 zeros. Can you write that code? We will take 2 minutes and try to write this code. If you don't know JavaScript until now, then it will take you 20 minutes. So don't feel overwhelmed. But if you know JavaScript, can you quickly write this code? Given this starter code, can you convert this? Can you write some for loops that brute force over a bunch of values and eventually prints out a string that starts with 5 zeros? I already have the answer here for you. 596138 is one such string. If I write 596138 over here, you will see it starts with 5 zeros. How did I find this? I wrote some code. The answer is already here. If you don't know Node.js, then just look at the solution. Don't try to code it yourself. If you know Node.js, probably should take you less than 30 seconds to code it. All right. We're taking a 1 minute break. Until then, let me try my best to open chat, even though I see a lot of people today. So I don't know how many of the questions I'll be able to answer right now, but I'm still opening chat. Okay, a few people found it. Hello. Yeah, let me quickly recap everything I've done until now as well. Oh, wow. Okay, let me just looking at the question. All right. I will explain the projects in the end. When we go through the doubt session, I'll do a deep dive into all the projects. To quickly recap, until now, I just did very high level stuff. I just told you why you should create a new currency. Then we introduced a bunch of what is hashing, why do you use hashing, basically something like this. You take an input, it outputs a hash. And then lastly, right now, we're trying to solve a few assignments. The assignments are intended for you to understand proof of work. But for now, we're just writing some code, nothing else. All right. We're at 2 minutes here. The code looks something like this. Let me copy this and paste it on Replit. The code says, I'm going to call a function called find hash with prefix 5 zeros. I have written a function that takes a prefix as an input, and now I am iterating infinitely. I repeat, I am running a infinite loop. I call this function, control reaches here. I select input to be 0. I select, kya 0 ka output kya hai? I first check what is the output of 0. I select input to be 0. And then I run an infinite for loop, which means I keep checking I convert this 0 to a string. I generate the hash of it and I check, does the hash start with prefix? Does the hash start with 00000? If it does, I immediately return the answer. Okay, there you go. That is the answer. If it doesn't, I do an input plus and then, the for loop continues. So if I don't get an answer for 0, I will increment it to 1 and then try again. If I don't get the answer for 1, I will increment it to 2, 3, 4. I will keep going like this. So I'm running an infinite for loop until I find this answer. What is a string that starts with multiple zeros? When I find it, I store it in the result. I log the result over here. If I click on run, what do you see? 596138 is one such answer. Can there be multiple answers? Yes. If I start this with 516139, then it will try to find me an answer after 596,138. So if I run this, now it finds me an answer 665,782. So there can be multiple solutions. That is fine. Multiple inputs can give you an output that starts with 5 zeros. The hash is different, but they both start with the same number of zeros. All right. Now the question is, this is the first assignment. I'll share why I'm giving you this assignment, but can any of you try doing this? What if I ask you, give me a string that starts with 9 zeros? You will keep doing proof of work. You will keep doing work over here to find a hash that starts with so many zeros. As you can see, it's giving me high CPU usage. It's just trying its best to find an answer. It's not able to, because this has now become a difficult problem. If the number of zeros that you want started is just 5, then it's an easy problem. If you want it started with so many zeros, then it is a difficult problem. And that is what Bitcoin mining is, right? If you've ever tried Bitcoin mining, what do people say? People say, get a very heavy machine, bhai. Get a GPU. You can use your 4 lakh ka GPU for Bitcoin mining. Why is that? Because the GPU is running this constant math. It is trying to find a string that starts with so many zeros. Cool. I hope that's sort of clear. Okay, when you are doing Bitcoin mining, effectively you're solving this problem, and solving this problem is called proof of work. If you are ever able to find the solution, as you can see, I am not able to find the solution. This is a very challenging problem. I will need a bigger machine. I will need more time. I might need 3 hours before I can find the solution. But when I find the solution, I can tell everyone, okay, this is my proof of work. Dekho, I have worked so heavily. I found a string that starts with so many zeros. I found a string whose hash starts with so many zeros. Cool. That is what proof of work is. Now I'm telling you, okay, when you're doing Bitcoin mining, you have to find, a very difficult problem. Let's say starting with 10 zeros. What you might do is, you will do proof of work once. You will just once run this infinite for loop, find the input. And now you have the answer. Let's say an answer came out over here. Let's assume the answer is whatever, some random string. This string gives you 10 zeros. You've done proof of work once. Now you will chill. Now you will be like, mera to problem solve ho gayi. Now my problem is solved. I will just, if anyone asks me, give me a string that starts with so many zeros, I will just give this string that I have found. I'm good to go. But Bitcoin needs to constantly mine. The miners are constantly solving a problem. So what do you think they are doing there? If everyone found, if you run this long enough, you will find a string that starts with 9 zeros, 10 zeros, 11 zeros, 12 zeros also. The point is, we want the miners to keep doing that. We don't want them to do it just once, which is why the miners, when they are mining, they have to do something closer to assignment number 2. Okay, every time they are mining, I keep giving them new prefixes. Okay, bhai, you have to find a number, but your input string should start with 100x devs. So they'll be like, yeah, shit, I solved the problem. I found this input, but this input doesn't start with 100x devs. So now they will have to resolve the problem. They will be like, acha, I will now have to find an input that starts with 100x devs and has some random number after it, which gives the output with 5 zeros. So they will have to do the problem again. So what are miners actually doing in Bitcoin? They are solving this problem. Okay, given a prefix, now how this prefix is calculated, we'll get to. But given a prefix, and this prefix keeps changing every time, they have to find